So I'm a senior lecturer here at Cornell. I came from originally psychology, then moved into environmental engineering. And then from there, I was really seeing that, in traditional environmental modeling, there was like quite a lack of including social dimensions into environmental modeling. So for my PhD, what I wanted to do was see how you can use systems engineering specifically on some social problem in order to develop new methods. A lot of people ask me, like, what is a social system? That's usually like the first question I get. And, how is this relevant for systems engineering? Because very often people like to put us in a category of like, oh, you're just working with users, social systems, socio-technical systems, that's just human system integration. So we look at, for example, things like the organization as a social system, but we're not just looking at this in terms of operations, because we also look on, for example, the political level. How does the organization relate to different kinds of organizations? How does that organization then work in different social systems? So now when anybody comes up to me and says, okay, my problem is in the social domain, well, now I can at least point them towards my courses, and then I can tell them how they can begin to address them by doing, at the very basic level, socio-technical systems architecture to actually find out what it is the problem that is you're trying to solve, and then modeling and simulation of that in order to do further analysis and really dig deep down further into it. But my teaching is focused on really from a methodological perspective. So what are socio-technical systems? How do you make system architecture of a social or socio-technical system? How do you then develop policy to that to change system structure to allow for desired emergent behavior? I'm trying a more untraditional format because all of the courses that I'm running are hybrid asynchronous, and it is super boring for the distance learning students, for those who are attending virtually, to always just watch recorded lectures. And for those that are virtual, we're doing everything on Ed Discussion through Canvas. People are just drawing things out, taking pictures and uploading them to Ed Discussion, and writing a sentence or two about what it is that they were doing. People have also been commenting on other people's work, and it's really evolved into a really nice platform for virtual workshopping. So in this course on socio-technical systems and policy, in order to get started on socio-technical systems, we've had to do really a foundation on system science. Really, what is systems theory? What is systems thinking? And then we move that on into particular social science disciplines. We work a lot with qualitative data, and we learn how to build that then into system architecture, which will then in the following course be run for simulation. We do have also some guest lectures to pull this out of the theoretical domain. This semester specifically, we're going to have guest speakers on cybersecurity and asset management. So I want to say too, for the next course, that everybody is welcome, even if you do not have a strong computational background. I'm going to be using system dynamics, which is rooted in ordinary differential equations. However, because of the sophisticated software, your knowledge will only really need to be very basic of differential equations in order to get started. And I will teach you all of that in the beginning. As I said, the most important thing for everybody is that you need to come with knowledge of systems. That is certainly the greatest advantage that you can have coming into any kind of math. Let's just say that is if you're able to understand what systems look like and how the architecture should be, it's just a half step to the math after that, putting equations behind the things you already know how to build. So a lot of people like to do optimization, especially in the MEng program, and they wind up taking a course called computational optimization. I'm not knocking that at all. I only want to point out is that in social systems, we consider optimization to be a dirty word. And the reason is that when you are optimizing, first of all, if you're optimizing and you're completely certain of your system, and you optimize a social system, it's usually based towards some sort of ideology. So who are you optimizing for? And what are their motives? But that's in a perfect scenario that you're actually able to do an optimization that's correct. However, when you're working with social and socio-technical systems, you almost certainly are not certain of what's going on because there are mountains of uncertainty when you do modeling and simulation of social and socio-technical systems. And so for those that like to do optimization, I always like to say that you will be precise if you do optimization in socio-technical systems, but you will be precisely wrong. And it's much better to be approximately correct than precisely wrong.